Welcome to the fourth lesson. In this lesson, we'll dive into a fascinating world of natural language processing, or NLP, where AI learns to understand, interpret, and generate human language. Think of it as a bridge between human communication and machine understanding. NLP helps computers to interact with us through spoken or written language. Let's see how it works. So, what is NLP? At its core, natural language processing, or NLP, is a field of AI that allows machine to process and understand human language in both spoken and written form. This involves tasks like speech recognition, language translation, and sentiment analysis. NLP enables machine to interact with us in a way that it feels natural, making it a key technology in virtual assistant, chatbots, and more. And examples of NLPs are a ChatGPT or Google Gemini and Copilot by Microsoft. What are the current challenges in NLP? However, language is complex, words can have multiple meanings, and sentences can be structured in different ways. Consider the word bat. It could refer to a flying mammal or a piece of sport equipment. Depending on the context, NLP systems need to learn these subtitles in language to interpret meaning correctly. Let's talk about how NLP works. Before machines can analyze the text, so how NLP works? There is an important concept which is text preprocessing. Before machines can analyze texts, it must first be cleaned, organized. This is where text preprocessing comes in. Preprocessing transforms raw and unstructured text into a structured format that can be understood by the algorithms. There are several steps that NLP takes to predict the next word or to identify what users want. First, we have tokenization. Tokenization is a process of splitting text into smaller units like words or phrases called tokens. For example, the sentence I love AI would be split into three different tokens. I love AI. These tokens are easier for algorithms to process. The next step is stemming and lemmatization. Next, we have the stemming and lemmatization. Both techniques are used to reduce words to their root form, which helps in reducing the complexity. Stemming removes the prefix and the suffix from the word, while lemmatization converts words into their base from using dictionary approach. For example, running becomes run, and better becomes good. While stemming is faster, lemmatization is more precise because it uses the correct dictionary form. Let's talk now about one of the most common tasks in NLP, which is called the text classification. Text classification involves categorizing text into different classes or labels. For example, determining if a product review is a positive or negative, whether this email is spam or not spam. How it works. First, sentiment analysis. One of the popular application of text classification is sentiment analysis. Here, the goal is to determine the sentiment behind piece of text, whether it's positive, negative, or natural. For instance, an e-commerce company may want to analyze customer reviews to understand public opinion about product. Next, we have spam detection. Another application is spam detection, where email system use text classification to determine whether an incoming email is spam or not based on its content. Using labeled datasets of spam or non-spam emails, a machine learning model learns to recognize the common features of spam messages, such like suspicious keywords, links, and formatting. Let's talk also about one of the most important tasks of NLP, which is named entity recognition. Another powerful NLP task in ER, which involve extracting important information or entities from texts. These entities can be named of names of people or organizations, location, dates, and many more. For example, the assistant of Apple was founded by Steve Jobs in New York on April 1st, 1976. So NER model would extract the following entities: Apple as an organization, Steve Jobs as a person, New York as a location, and April 1st, 1976 as a date. This process allows machine to understand and structure the data in a way that it's useful for more advanced analysis. Let's talk now about language models. Language models are the heart of many NLP systems. These models predict the next word in a sentence or generate human-like text. Models like GPT and BERT and transformers have revolutionized the NLP by leveraging deep learning and attention mechanisms. GPT, which is Generative Pre-trained Transformer, is a model designed to generate a human-like text. It's trained on huge amounts of text data and can generate paragraphs, answer questions, and even write essays based on given prompt. For example, you could ask ChatGPT, tell me a story about a cat, and it would generate a creative story and as a response. Next, we have BERT, which is bidirectional encoder representation from transformers, which is designed for understanding contexts. Unlike traditional models, BERT reads the text in both directions, from left to right and right to left, helping it to understand its full context of each word. It's incredibly effective for tasks like question answering and language translation. Transforming and attention mechanisms. Transformers are the architecture behind models like GPT and BERT. Their key features is the attention mechanism, which allows the model to focus on important words in a sentence, regardless of their position. This makes transformers highly effective at processing long-range dependencies in the text. Let's now look at some of the real-world applications of NLP that we encounter every day. Chatbots and virtual assistants like Siri, Alexa, and Google Assistants uses NLP to understand and respond to user queries. These systems analyze the user speech or text inputs, understand the intent, and generate and operate responses. The next example is the text summarization, which is another exciting application of NLP. Involves condensing long documents or articles into a shorter, more digestible versions while retaining the most important information. For example, a news app often use text summarization to provide a quick overview of breaking stories. Third is the language translation. Language translation like Google Translate uses NLP to automatically translate text from one to another. With advanced models like BERT and GPT, translation systems have become more accurate and precise, understanding the context and the expression much better than before. Now let's recap what you have learned so far in this session. We have covered the fundamentals of natural language processing, NLP. We have learned about the key processing techniques, including the tokenization and lemmatization, as well as the text classification methods like sentiment analysis and spam detection. We have explored the advanced language models like